Okay, so let's calculate the following limit. So we'll start off, very easy, almost kind of a review of last time. Okay, so this function does not have the direct substitution property at x equals 3, right? So the function x squared plus x minus 12 over x minus 3 does not have the direct substitution property at x equals 3. Right, and again, it's a very trivial reason, right? Substituting in x equals 3 would give me a nonsense expression. It would give me something divided by 0. So obviously that doesn't work. Now, we did see how to work with this last time, right? So the idea was, even though this function does not have the direct substitution property, we can use limits and algebra to make it into the form of a function that does have the direct substitution property. So let me kind of write that down as our general strategy. This is going to work for most of the examples that we're doing today. So we use algebra to transform f of x into a function with the direct substitution property. Okay. So this was almost the last example we did. It was like the next to last example we did last time, right? Something very similar to this. Right, what would we do first? We would say, okay, let's use some algebra. We can factor the top, right? X minus 3, x plus 4. And that's always true because we're always allowed to do just factoring, right? Factoring doesn't really depend on anything, like something can't be 0 or anything. But now we want to actually say, now I want to cancel out the x minus 3's. And we actually did talk about this last time very specifically, right? Why am I allowed to cancel out the x minus 3's, right? Last time we said it is not true. So let's actually kind of review that very briefly. X squared plus x minus 12 over x minus 3 is not equal to x plus 4, right? We discussed that last time, that these two expressions are not equal to each other. However, in the limit, I am allowed to cancel out the common factor and then write down that this is the limit as x approaches 3 of x plus 4. Can someone maybe remind us? You can also cue your mic if you want to talk. Why that's okay? Why is this step okay? Why is this equal sign okay? Especially in light of that red text.
Because we're told that x approaches 3.
So what does that tell us exactly, Artie? If x approaches 3, can you kind of alternatively describe what does that mean to you, that x approaches 3?
That the x value is getting closer and closer to the point 3.
Okay, it's getting closer and closer to the point 3. What about exactly at x equals 3? Does someone want to take over? What about exactly at x equals 3? What would you say?
That it doesn't equal -4.
So -4. So we're not setting this equal to 0. We're not saying that this is equal to 0 and somehow x equals -4 is kind of irrelevant. The value x equals -4 is not relevant right now. The only relevant value we're really looking at is x equals 3. And so right now I'm kind of asking, maybe I should make the question a little bit clearer. Artie said it's okay to cancel these factors because x is approaching 3. And so I just want to make that a bit more precise. And I think some people in chat actually have already said it. Thomas said, limit does not care about what happens at x equals 3, right? That's what I want you guys to kind of remember, right? The limit doesn't care about what happens at x equals 3, only near x equals 3. So this limit symbol tells you that x is not equal to 3. Limit symbol tells you x is not equal to 3. So that means the cancellation is okay. like what a few people said, this function is undefined at x equals 3. That's why you have to take a little bit of special care. And someone also asked about, is there a jump at x equals 3? So we're not going to talk about jump. We're not talking about discontinuities until a couple lectures later. But this is actually going to be what's called a removable discontinuity. There's a hole in the graph. Okay. And then finally, this equal sign. Now I can just plug in x equals 3, and I get 7. And why can I do that? Because x plus 4 is a polynomial. So it has what? It has the direct substitution property. Okay. All right, so notice how what we have actually done, now even though this was a simple example, it kind of shows you the general procedure. The general procedure, what did we do? The original function, which did not have the direct substitution property, you could not plug in x equals 3 into the original. You should also not think, oh, if I plug in x equals 3, I get 0 over 0. That's undefined, therefore the limit doesn't exist. That's also nonsense. I'm actually going to write that in the next limit as well. But the big thing here is I have a function that does not have the direct substitution property, and then I use algebra to rewrite it as a function that does have the direct substitution property. And the only reason we can say that these two limits are equal is because the limit symbol tells us that x equals 3 is not relevant. The only thing that's relevant is what is happening near x equals 3.